Hello, this is John Carter. Hopefully I will be sharing my video with you very soon. I'm trying to watch my live stream to see if it is live. I'm doing a little setup right now. So there's going to be a little bit of a delay before I actually start showing you my screen, but I can do that anyway. So the idea here is to try to make sure that I'm in good focus before I switch over to the moon. So I'm looking at a star here, and I can see that I'm in fairly good focus. Now the screen that you're looking at, I have two 27-inch monitors in my observatory. This is one of them. This is the other one. So I'm just going to switch over and look at the one view for the one image so that you don't get confused and you get a larger display. So now we're just looking at the one image. This is the software package that I'm using called SharpCap Pro. So SharpCap Pro is what I'm going to be using to look at the moon. But in order to actually look at the moon, I have to be switching over to that. So let me change the view again so I can look at the other display, which contains Sky Safari Pro. And down here is the moon. And what we have been looking at is M78. So I'm going to click on the moon down here. And then up here, I'm going to say go to. Now this is going to cause this guy down here to look really, really bad, so I'm not concerned about it. In fact, we won't be needing that at all. This is the application that I use for managing the focus on the telescope. So now that we're at the moon, let's switch the view again over to the other display. And as you can see, it's quite bright because the moon is that bright. So I go down to 12 milliseconds, which is going to be a short enough exposure to be able to handle that, but I also have to turn my gain all the way down. So I had it turned up for the other purpose. So there we have the moon, but we're looking at a view of 200%. So let's go back and look at the auto view, which is allowing it to fit. So we can see that actually 12 milliseconds is still a little bit too bright. So let me, oh, and I know why that is. So I need to add a filter to this, and that's apply the flat. So once I apply the flat, that's going to change the appearance quite a bit. It's going to dim it down a lot so that we can actually see it at 12 milliseconds. It'll take a little while for it to catch up. And we're looking down here at the red and the blue and the green, and the red is quite high, so we need to knock the red down quite a bit. And we need to increase the blue to try to get them to where they're lining up pretty much. And as that continues to take images, we'll start seeing a better and better view. And it looks like 12 milliseconds is still a little bit too high. So we'll see if we can knock that down a little bit. For 8 milliseconds. Hold on. Can't believe it, that's still too high. before my computer crashed. 12 milliseconds was just right. So you notice as I keep coming down in exposure, I see a better and better moon. So I'm going to try 0.5. That's looking a little better. Now I'm going to zoom in on it a little bit. So let's go to like 66%. That'll pretty much fill the screen. So there's the moon. It looks a little silvery. I'm going to check the histogram again a little bit different way by clicking on this. And then also check the logarithmic value on it. So we notice that it's all the way off, so it's completely on the edge here. So in order to bring that edge up, I've got to change this offset value a little bit. Let's see if that'll help. That's a little going up. We want to get a step on that far left side. And that'll change the color of the moon as we do this as well. All right, so we got a little bit of a step in there. And notice we've got a lot of change. So we still need to knock the red down a little bit. So I'm going to roll that back. And I'm really concerned that it's a totally different setup and, you know, for the exposure and everything that I had just minutes ago. So looking at it from this perspective, I don't have a good contrast, black to white in here. Whereas I did before, and it's just bothering me that it's not working the same way as it did earlier tonight. So what I had earlier tonight was quite a bit different as far as the settings are concerned. Now, I do know that there's quite a bit of delay between when I actually speak and or do something on the screen and when you see it. It's almost like a six-second delay, something of that nature. But there is the moon, and we've got a fairly good focus on it, but I'm just not liking this contrast. Now, this image that you see over here is what I use to control the mount with as far as moving it around. And what I like to do is put up a crosshair on the screen to tell me where is the center. The center of the moon is actually right about here. So I need to push the moon up a little bit. So I can do that with this control right here. Doesn't take much. A little tap here and there. So that's about the center of the moon. If we had a full moon, we would probably be able to see better that it's actually cutting the moon in half. So there's quite a bit of portion of moon that's not being visible right now, and that's down here. So that's approximately the center of the moon. I'll get rid of the crosshairs so that we can see the moon. And I'll tinker around with the red, green, and blue controls some more. So notice the camera has a temperature. It's cooled. It's a cooled camera. And I've got the temperature set to be minus 15 degrees Celsius. And we're fixed right now at minus 14.5. And that's about as cold as it normally gets when I set it to minus 15. For the white balance is, I have that white balance set in order to enable me to actually see the moon a little bit better. Okay. So this gives me a little bit better representation of the moon just by clicking on this to get auto adjust. So we're a little bit too hot on the red. So I would need to back off some more on the red. It hasn't helped an awful lot because we're almost down to minimum anyway. And maybe a little bit too hot on the blue. So let's look at the histogram again, the blow up of the histogram to see what it's looking at. That logarithmic set. So we see that the red, green, and the blue lines are pretty much overlapping, and that's where we want it. And in reality, the ideal condition is to have the red leading the green and the blue falling behind the green. So that would be an ideal condition because our eyes are tuned more to the yellow and the red than it is to green or blue. So now we're seeing more contrast in here just by making this final adjustment right here. If I turn that auto stretch off, then we get this image, which is like, where did it go? Right? Yep. Back to this. There we go. Leave it alone. Not too pleased with this red tint running through here. But I do have a moon filter attached to the camera. What the moon filter does is it allows me to take an image of the moon, actually, because if I didn't have the moon filter in there, then I wouldn't be able to adjust my exposure down low enough to be able to see the moon. Now, earlier today, I was getting some pretty good images of the moon. And I would like to be able to show them to you. I've actually posted them on Facebook. So if you were to go to my Facebook, you would see all the images that I've been taking tonight. And they were, I thought, quite good just for single shot images. Now, the way we normally take pictures of the moon is we set the camera up in video mode and we capture a video of the moon for about 1 or 2 seconds, or maybe 5. And then we take the output of that video and run it into another application. And that application takes each individual frame of the video and stacks them one on top of the other and aligns the images from one frame to the next. By aligning the image, it enhances the detail that's in here. Because right now we're looking at the moon through the atmosphere. I'm going to blow this up quite a bit so that you can see what the atmosphere disturbance is actually doing to it. So if you'll notice in here, you get a lot of noise. There's a lot of noise in this image, and the edge isn't all that sharp and bright. But I did spend a little time making sure that I was about as focused as I can get. And also you'll notice as time goes by, the moon is creeping. It's going in one direction or another. And that's because the tracking mechanism on the telescope isn't precise. So when I'm taking pictures of the dark sky, objects in the dark sky, I can see a moon, or not a moon, but a star. And if I track on a star, then all the images that I take will be overlapped one on top of the other. So I'll give you an approximate idea. And this is about what you would see if you had a pair of binoculars looking at the moon. So I can pan around here. Now ignore those lines that you see. That's an artifact of the application, not the camera. So here's another area of interest to point out. Notice the little red rim that we have around the edge of the moon. That again is caused by the camera, the lens on the camera, and the lens in the telescope. So we would have a red fringe on one side and a slight blue fringe on the other. And this is called chromatic aberration. And if you just take a Standard pair of telescopes off the shelf, you know, cheapies like $20 not telescope, binoculars, $20 binoculars. This red and blue fringe that you see is going to be enhanced a lot on binoculars because they're not adjusted for the chroma correction. So the telescope that I am using, which is a Celestron 14-inch Edge HD. The Edge HD is basically, it's designed so that we have sharp pinpoint stars to the corners of the image. That's what the Edge HD is supposed to be about. But as far as removing all the chromatic aberration, it's not quite there. Now, the chromatic aberration that we did notice there can also be attributed to the fact that there's an adjustment that you make on every telescope of this type. So there's two types of telescopes. One type is the refractor telescope, and the other one is a reflector telescope. So a reflector telescope has a mirror, in fact, two mirrors in it. So the light comes in from the aperture, the open end, goes all the way back to the opposite end of the telescope, bounces off of the primary mirror, goes back forward to the front, and bounces off of a secondary mirror. And then from the secondary mirror, it bounces back and goes back out through the center of the primary mirror, which has a hole in it, into the eyepiece on the back. So that's called a Schmidt-Cassegrain telescope. The other one is where they aim the secondary mirror to where the light goes out the side of the tube, and that's called a Newtonian telescope. The Newtonian telescope design came before the Schmidt-Cassegrain. And then they've added other advanced features to the Schmidt-Cassegrain to try to remove the chromatic aberration, increase the sharpness, and improve on the color all the way around. So most of this color aberration that you see in here is actually caused by my moon filter. The moon filter cuts the light down considerably. Probably only 40% of the light passes through that filter. So without that filter, I wouldn't be able to get an exposure of the moon. And also, when I add that filter to it, it changes the color quite a bit. So it gives it a more orange presence. So what I have to do is make an adjustment in the red, green, and blue over here to correct for that color change that happens as a result of the filter. So if these were all set to the center point, like where the green is, I never adjust the green. I just leave that alone and adjust the red and the blue around it accordingly. So if I just make all of these the same, now 2014 is the center point. So I'm going to take that and I'm going to make this one 2014. And I'm going to make this one 2014. And what you're going to see is a really bad color. So now all of these are at the center point, and we have that orangish color caused by the moon filter. So this is why I have to make these adjustments over here to compensate for what the moon filter does. We knock the red down, increase the blue. And what I think you'll notice is happening, I got a little bit too much blue. We're looking at this edge of the histogram right here. And what we want to do is have the blue trailing the green a little bit and the red a little bit of advance. Now I've got the red too much or the blue too much, so I'm going to back off on the blue a little bit. And then I have to also back off more on the red. Try to bring those closer and closer together. I'm not quite able to do that, so the red is still quite a bit advanced. But you'll notice we're getting more of a black and white exposure of the moon. So if all of these were perfectly lined up, then that's what we would call white balance. And we don't want a perfectly white balance when we're taking astrophotography images. And like I say, the color, our eyes are a little more sensitive to red and less sensitive to blue. So if the red is leading the green a little bit and the blue is trailing the green a little bit, then that would be what I've been told is a more accurate rendition for true color. All right, so let's get rid of this so that we can see the moon again. I'm going to turn the crosshair back on. And you notice we're off center again quite a bit because the Earth is shifting and the moon is drifting. My telescope isn't absolutely perfect. So I've got to come over here and readjust and get back to center. Because if I don't do that, eventually the moon will just crack all the way out of existence. That's close enough. And we can back off of that 100% and go back down to 66, which will give us a little bit better image of the whole thing. Turn off the crosshairs. So as you can see, by increasing the gain, now the gain adjustment, this offset right here, not the gain, the offset, that adds a step at the beginning of the histogram. And that's actually essential when you're taking astrophotography images, because that step at the beginning is letting you know this is black. So there's typically nothing there in the black area. If I back off on this, then that's going to give me more of a black area, which is probably what you're accustomed to in seeing astrophotography images. If I turn it all the way off, then we have a pretty bad image. Now let's turn green. And we can probably adjust for that by increasing the red, increasing the blue a little bit. Too much. Yeah, so we can, we play around with these adjustments. And this is just for visual observing. So if I'm taking photography, actually, I probably wouldn't even make any adjustments here. I'd leave these in the center point and do my white balance adjustment in post-processing. So I would take the image with everything set to the central point and then stack a whole bunch of these images together. And the way I can do that actually is come up here to the capture and say, I want to capture, start a capture process or sequence. So it says perform a sequence of captures and how many, and then interval between the captures. And then if I say start, then it's going to take that number of pictures and store them on my computer. But first I would have to make sure what the name is that I would be capturing, the moon. It's a light frame. There's different kinds of frames that I can take. There's a dark frame and a flat frame and a bias frame and a dark flat and so forth. These are all part of astrophotography and what I'm accustomed to doing when I'm taking pictures. So I have to take one of each of those, a set of each of those frames, and then combine them for a good astrophotography image. This FX, don't worry about that. So here's the zoom, and then over here we have a focus assist if I needed to do that, but I can't use the focus assist on the moon. It's just not going to work. Focus assist is where I'm looking at a bright star, or not a really bright star, but a star instead of a moon. So now I've got my offset all the way down to 0. We've got a hard contrast between the two. And that's a little bit too much of a hard contrast. So I'm going to increase this back up to, 30 is probably good. But then I have to readjust down here. Got too much red. Yep. All right. So now I've got pretty much of a silvery moon, which is actually the color of the moon. It's not green. It's not blue. It's not red. It's actually a silvery color. It's black and white. So that's why we have this grayscale in here. So the white light reflected off the sun is white light. Everything coming off the sun is white light. And we know that by holding a prism up and watching the colors come out of the prism, like a rainbow. It consists of everything from red at the high frequency to blue at the low frequency, and the green and the yellow and brown and all that are mixed in. And we know from experiment that if we combine all the colors of the rainbow, we get white light. So white light going into a prism gives us the rainbow coming out of the prism. And if we turn that around, then rainbow colors going in gives us white light coming out. Mixing paint is a little bit different. Those are reflective colors as opposed to radiating colors, the light colors. So there's our moon. We have all these craters down in here. We have a big one. This is a Mare. We call it a Mare, which in the old days, they thought it was a sea or an ocean. So they gave it the name Mare, which stands for ocean or sea. So these are the Mares, the big craters. Now on the other side of the moon, there's a humongous crater. And that humongous crater is almost 60% of the moon. It's about that big. And it's full of other impact craters inside of it. And I was watching NASA earlier today, and they were talking about that crater. And they were saying the depth of that crater is like 13 kilometers. 13 kilometers deep from the edge of the crater down to the center. That's a pretty big and pretty deep crater. The other thing that they mentioned about the moon is, let's stop that. The other thing they mentioned about the moon is the crust on the near side of the moon is thinner than the crust on the far side of the moon. And they also mentioned that the moon is actually receding from the Earth at about 1 inch per year, 1 to 2 centimeters a year. And that receding is caused by the tidal forces between the water on Earth and the moon. So there's an interaction between our tides and the moon. We think the moon is causing the tides, but the tide is actually affecting the moon. So as the moon goes to one side of the Earth or the other, we have a pull on the water. So whatever side the moon is on, then that side of the Earth and the opposite side of the Earth, we have high tide. And then at 90-degree angles, we have the neap tide or the low tide. I think neap tide is low tide. I'm not a geologist. I don't pretend to know that stuff. So we have 8 o'clock. We're halfway through the 1 hour that I have allocated for this exhibition. I'm going to switch back over to the other screen now to give you a little more clue on what's going on over there. So Sky Safari is what I'm using to actually find things and go to things. So this part is the scope control. I can actually move the scope left, right, up, and down with these controls. And this gives me the rate at which it's going to move. If I move this down here, then as I adjust these, it's going to go slower. If I move that to the far end, then it's going to go faster. Here's the disconnect from the telescope. There's the go to. So if I click on something over here and say, I want to take a look at that. So I click on it. And what that'll do is it'll highlight it. As you can see right there, you get this little flashing pointers around it that goes back and forth. And then I would say go to, and literally the scope is going to take off and go to that location. Explaining these lines a little bit. This green line right here is called the meridian. It's the separation between the west side in this case, the east side of the sky and the west side of the sky. And this line down here is a 30-degree point. And I have that set at 30 degrees because there's absolutely no sense in trying to take pictures of anything below 30 degrees because that's where the atmosphere is. And if I take pictures through the atmosphere, it's going to change the color tremendously. It's going to cause color aberration for sure because the atmosphere acts like a prism and separates the red, green, and blue light. So I'll get more color aberration trying to take images through there. So I want to stay as close as I can up here in the, the top center. Like there, I'm going to back off on the zoom here because I'm zoomed in quite a way. Down here, this green area is considered the Earth. So right there is the horizon. Here's south. So we're pointing more to a southerly direction. This orange line that you see here is the ecliptic. That's the line that the Earth, the Moon, the Sun, and all the planets travel along that. You notice we've got Neptune over here. Over here we have Pluto and Saturn and Jupiter. So they're all going along the ecliptic. And the other lines that you see in here are called asterisms. And these asterisms are just connecting the dots between stars to give us figures. Notice this one looks like a butterfly. You could call it a butterfly. There's another one that looks like a kite. And that's in here, there it is. So here's one that looks like a kite. So it's called the kite. And we have other asterisms like here's the summer triangle right here. And then inside the summer triangle, we have the Northern Cross. But this is also Cygnus the Swan. Here's the head of the swan up here with the star Albareo. Here's the tail of the swan with the star Deneb, and so forth. We have the wings of the swan. And then there's this arrangement. This is, let's say, well, we got the Western Veil Nebula in there too. So this is showing us that there's different objects in there. And there's the Andromeda Galaxy. I guess you're familiar with that. So that's just to give you a clue of Sky Safari and how I use it to actually find things in the sky, go to them, and capture them. And this application over here is my focuser. I connect it to my telescope. There's an electronic motor on my telescope, and I can control the in and out using this, and that helps me focus it. My hand paddle out there actually looks like this. So if I wanted to do it manually, I would pick up the hand paddle and manually change it there. And then the other one that I put away is called, let's see if I'm going to find it. There it is, PhD2 guiding. So notice these little dark spots that we have, or the light spots that are in here. These are stars. You wouldn't normally see this. I'm looking at it from a very, very low exposure right now, but I don't even have the exposure running. So I was to click here in order to start the exposure of the small telescope that this camera is looking through. So the small telescope is called a guide telescope, and the camera attached to it is called a guide camera. And this application, PhD2 guiding, is controlling the camera. So that's what this exposure down here is for. I normally set it to 3 seconds when I'm looking at objects in the dark sky, not at the moon. So if I look at the moon, I have to set it to the very lowest possible exposure. So let's turn it on and see what it looks like when we're looking at the moon. So there's the moon. I can't get a low enough exposure to be able to see any detail on the moon. And that's not the purpose of a PhD2 anyway, to be able to look at the moon. If I could, I might be able to find a white spot on the moon and say, pretend that's the star and track on it. So that's a possibility, but I'm not going to go there. All right, that's enough of that side. I'm going to switch back over, look at the moon again. And what we're going to find is that the moon has actually shifted some more. So we're probably going to have to recenter it. Yep, we're way off center. We got to bring it back down here again. So I'm going to use these controls and this one. After a while of playing with the controls, you get familiar with which one I should hit and for how long in order to get it to move the way you want it to. So you would think this would be up and down and this would be left and right. Well, it's, you know, this is up and down and this is left and right. It's just rotated. And part of that is because of the camera. The camera's not rotated to match what this looks like right here. In fact, what I can do, I'm going to switch back over and show you the view, what we would get. So I'm going to zoom back in on the moon, make sure that we're actually on the moon. So the moon is centered. Now I'm going to zoom in on that. And you're going to see a box. So this box is actually the view of the camera. And you'll notice the angle of the box right now. So that's saying, as I zoom in a little bit more, you'll notice the dark side of the moon, or the shadow of the moon, is off to this side. But when we look at the actual image that the camera is taken, it's on the other side. And that's because the telescope camera and lens on the telescope flips everything. So what you see is not what you get. So let's go back to the image of the moon, and you notice it's flipped. And you can correct that after you take the picture. You can flip your images any way you like after you've taken the picture and make it look like would if you were, you know, line of sight using your eyes. Now, I am not monitoring the YouTube, so I have no idea if anybody's asking questions out there. I'm not even sure if the Q&A chat room is even live. But if you want to send me questions, you can use my email address. And you can get my email address by finding me on Facebook. And my Facebook name is just simply J Carter. J Carter is my Facebook. Or my phone number is my Facebook ID also. If you look for John Carter, there's going to be a couple of them out there. So find the guy that's wearing a hat, cowboy hat. That's me. There's 20 minutes left in the hour that I've allocated for this. Not sure how many people are actually with me. I have 6 people actually with me at this point in time. Okay, I did another automatic adjustment here, and that took care of a lot of that redness. So this did an automatic correction inside here, and we've got a much better image going, but it's a little bit too bright. So what I'm going to do is turn down. I'm going to go to 400 milliseconds. And I can actually take this offset and bring that back a little bit. That'll give us a little more contrast to the image. It's looking a lot better. Yep, looking so much better. Yep, another adjustment here, and it tweaked it in, so we're going to have a fairly good contrast going for us. We see these white rays coming off of this crater. This is ejecta material, so when the asteroid hit, it literally knocked a bunch of the material off the moon, and it went out in these rays called ejecta. Then you see the same thing over here and up here. You see these rays where the material just sprayed out. Now, why it goes in rays like that, I don't know. Just the nature of geology, as far as I'm concerned. So if we zoom in down here and look at this, you notice there appears to be something sticking out of the center of that crater. So let's zoom in on that and see what we can find out about it. Now I got it scroll down. So as you can see, it appears like there's kind of like caldera in the middle of that. And this could actually be another impact inside that crater. Could be. Could also be a caldera as a result of this impact that happened, millions or billions of years ago. And because there's no real atmosphere, no real moisture on the surface of the moon, there's no erosion that occurs. So anything that struck the moon a million years ago is still looking the same way today. Now you'll notice a lot of this stuff, there's impacts that just overlap. And that's just thousands and thousands of asteroids and a few comets that come in and splat on the moon. And the reason we see these craters the way they are today is because there's no erosion activity, no wind, no air to move things around. It's just what's going to happen as a result of asteroids hitting. Asteroids are still hitting the moon. We have several a year that are being recorded that are hitting the moon. So we've got cameras pointed at the moon constantly now that are recording asteroid impacts. I forget the name of the project that's actually doing that. The really bright spots, now this is the thing that just blew my mind when I read this. The really bright spots that you see are rougher than the dark spots. The dark spots are smoother than the bright spots. You would think it'd be the other way around. A mirror is really smooth and it reflects, right? So this is acting like a mirror reflecting more of the sunlight, but it's because of the irregular shape of the material at that point that's causing the greater reflection, whereas over here, and it's flat. So when the light strikes it and goes off in a different direction instead of scattering in all directions. So we can look at it from that perspective. Light hits this material here, scatters in all directions, so we get more light coming toward us than we do with this stuff here. So that's the explanation that I read a long time ago. I don't know if the scientists would agree with that, but that's what I read. And the last time I took a class in astronomy was in 1991. So all the knowledge that I know today is, about astronomy is about as old as it gets. 21, almost 30 years old. And then you can add my age to that. And you can probably figure out that what I heard yesterday is probably not going to be what I repeat today because I don't remember what I heard that well. So everything I'm telling you, take with a grain of salt and do your research, verify everything that I've said, because that's the fun of learning as far as I'm concerned. Now I'm noticing that it doesn't appear to be too focused here. So what I can do is I can switch over and bring my camera or my focuser into view. So you're just going to grab that and bring it over here so that we have it on top, and then go back to the one view, display one. And now I can make the adjustment here and see what's going to happen to the view. You notice it's getting fuzzier and fuzzier. So obviously I got to go in the opposite direction. And I'm only tapping on it like 1 second or less. Half a second tap each time. And yeah, it's starting to come into better and better view. Now there is a way to focus this by actually going to a nearby star and focusing on the nearby star. But if I did that, then I would have to change my exposure for the star and then come back here and change my exposure again for the moon. So it's starting to look a little bit better, not as fuzzy and out of focus as it was. So I'll keep going in that direction and see if it gets fuzzier at some point. Yep, fuzzier there. So we can come back to. So these are the games that I have to play now. One of the reasons that it goes out of focus is the telescope itself has been out in the sun all day and it heated up and the mirror got hot. All the mirrors got hot. The camera got hot. Everything got hot sitting out in the sun all day. And starting around 6:30, when the moon came up around the horizon, is when I started taking images of the moon. So as the telescope cools off, I have to keep adjusting the focus because the mirrors warp, the tube of the telescope changes configuration, and all of that affects the focus. So this is about as good a focus as I think I can get without switching over and going to a star and doing an automatic focus on a star. Because I just have to go by how much detail I'm getting out of here when I'm doing it with the moon. If I was looking at a star, I would see the star go to a pinpoint and then back out again, like it would bloom. And then once it's at a pinpoint, then I know I'm focused. And here, because I'm looking through the atmosphere, things are not actually as nice and clean and the way I would like it. Okay, so enough of that. We don't need that anymore. And I just realized that I could have stacked up my Sky Safari in behind this application and just switch back and forth instead of going from one screen to another. Live and learn. All right, let's go back now. Notice we're at 250%. Let's go to 100% just so you can see pixel for pixel, what does the camera see? So this is what if I were to take a picture and, display it on my telescope, this is what I would see. I just clicked on an icon there and that's going to bring up an application that I don't want to use. So that's what that blue circle is about. It's trying to bring up that application. I'm going to take up memory. So as far as the color contrast, I think this is looking really good now. It looks out of shape, but that's because we're not seeing the rest of the moon. So I'm going to go back to auto. Now in auto, we're seeing the full frame of the camera now. This is exactly what the camera sees. So you'll notice the moon is just a small part of what the camera sees. So that's why I had to zoom in. Otherwise, you get kind of tired of looking at this dinky, tiny little moon. So to me, 66% is probably good enough because it kind of fills up the field of view. Give you something to look at rather than that dinky little moon. Oh, we have 7 people. Somebody just joined. Thank you. I was kind of expecting like 100. I advertised the heck out of this thing and sent out emails to well over 200 people. Can't expect everybody to be interested in looking at the moon anyway, or listening to me explain all this stuff about this application. So one of the things that I do in my spare time as an amateur astronomer, I'm the president of the local Prescott Astronomy Club in Arizona. Have been for a little over a year. And I don't know how long I'm going to be able to maintain that position. We'll see. And if anybody wants to be president, I'm more than happy to let them take it over. And we're having nominations in our general meeting next month, and we'll be doing elections in October, or November rather. And then the new officers will take their position in January. So we're looking for a president, vice president, secretary, treasurer, and 2 directors at large. Well, join our club. It's cheap. Uh, it's minor, and you can have all kinds of fun. We have a picnic every year when we're able to get out into the open and mingle like that. We also have our normal in-person meetings at the Touch Mark at the Ranch, which is the lodge up on the hill over by the shopping center up on the hill. I'm trying to think of the name of the shopping center. Yeah, there I go again. I'm actually quite pleased with this picture now, the way it looks at this point. And every time I click on auto stretch, it makes another minor adjustment and gives me a little bit better image. But notice the offset that I've got over here on the white, on the red and the blue in order to get that silvery look of the moon, that grayscale appearance. Otherwise, it would have an orange look caused by the filter. So I do have to make these white balance adjustments. That's what they're there for. And the temperature of the camera right now is at minus 14.9. I've got it set to go to minus 15, and that's centigrade. And it's on automatic, which means it's going to keep that temperature. So even if it gets colder outside, it's going to try to keep it at minus 15 degrees, even if it gets down to minus 30. So the camera itself, without being cooled, will heat up all by itself. And it could get hotter than the ambient temperature, which we really don't want to do. We want the camera to be as cold as possible. I would like it to be down at minus 50. That would be great, but the camera can't go any colder than 35 degrees centigrade below ambient. So that's the range of the cooler on the camera. Now, a cooled camera gives you an advantage over a non-cooled camera, in that a non-cooled camera continues to heat up as you're using it. And the more it heats up, the more background noise you get in the image. So a cooled camera will give you less background noise than an uncooled camera. Most of the noise that you see in here is caused by the atmosphere. Another artifact of any camera is going to be hot pixels. A hot pixel is one that's always on. So if I were to take a number of exposures here and really dig deep and look in this black area, I would probably see a number of red, green, and blue pixels. And those are the hot pixels. They never turn off. Every camera is like that. So we take a series of dark images, and that's what is up here. You know, if I go up here and I say I want to take dark frames, and then I come over here and I say I'm going to capture a series of darks, and then I'm going to use those darks and subtract them from this image. When I subtract the dark from the light, then all those hot pixels magically disappear. Or at least most of them do. The ones that don't disappear, you can get rid of in post-processing when you're actually processing the image. But if I'm not really concerned about how sharp this image is, I would just take this picture and print it out and put it on the wall. I mean, that looks good enough for me. Pixel peepers, that's what we call them, pixel peepers. They like to zoom in on it and say, well, just how sharp is your picture? Let's go down in there. Let's zoom in on it. Ah, it's not very sharp. You could have done a better job. Yeah, and look at all that noise that you've got in there. You could have done a better job. Yes, I have done much better jobs. I have taken multiple exposures and stacked them up, post-process them, come out with super clear, sharp, distinct images of the moon. It's amazing, but it takes time. And if you're not interested in all that, snap a picture as an example. Take a snapshot right here. Take a snapshot, it saves it on my computer. I can go back to that later. I can post-process it if I want to. I can probably sharpen it up a little bit if I wanted to. I can do a little noise reduction on it if I wanted to, make it look a lot cleaner and sharper than what you see here, just off of a single image. Or I can take a number of images, stack them together, and then do the post-processing of sharpening, noise cancellation, and other changes that can be done to it. And that's what people do. We come up with ways of making our life really interesting to take wonderful pictures. So I'm going to switch over again to the both displays for now so that I can do one more thing. And that one more thing is to grab this. And this is my view of the computer, basically. And I was going to show you some pictures. So the picture that I've got here, this one, is called the Trifid Nebula. So this is an image that I took. Notice the stars are a little bit bloomed, and if you go pixel peeping in there, you'll find that their stars aren't completely round, they're a little elongated, but the colors look nice. So I didn't do an excellent job in taking this picture because maybe my exposure was too long and the telescope drifted a little bit, even though I was guiding, and we got elongated stars in there. But this is the kind of picture that I can take with very little effort at all. In fact, the application that I'm using called SharpCap will actually give me that kind of a result without me doing anything. I just point it up there and go over here to where it's called Live Stack. And what Live Stack is going to do is it's going to try to take one picture and then another and then another, and it's going to try to align those frames. And if you'll notice, everything looks really, really weird. And that's because we've got to change all the exposures, you know. So now it's looking a little bit better. Yeah. So we got to turn this one off, undo that auto stretch, and then turn this auto stretch on. Now it only took one image, and the others it's ignoring. And it's ignoring them because it can't find something in the moon to be able to stack them up and make it look right. So if I were taking a picture of that Trifid Nebula instead, it would be able to stack one on top of the other, and eventually I can get 45 images that are all stacked one on top of the other, and then I can save that and go and post-process it and have fun like that. So here again, we got too much red, we got too much exposure, and not enough blue, and all that. So I have to make these minor adjustments, and then once it's all done, then I can save the image. So notice it's ignoring 13 frames so far, and it's only got one. Now, if I turn this off, then it's going to save. I don't want to save none on that. So now it's trying to stack them up. Now it's got 3. Notice how fuzzy it's getting? And that's because the moon is moving, and it's saying if I stack one on top of the other, I don't have any reference points from frame to frame, so it's going to be really, really weird. All right, so that's what happens. So now I'm going to clear the stack, start from scratch. It's going to give me just one to start with, and then it's going to ignore all the others. So there you go. So I could save this image, and then I could process it. We're just ignoring this live stack mode completely. Come back to here and do the auto stretch. And just take a snapshot, and then another snapshot, and then another snapshot, and then do my own stacking off to the side. where I can come up here and say capture and automatically say, I want to start a capture and say, how many do I want? Do I want 10 or 100 or 1,000? Because this is a really short exposure. Why not take 1,000 of them? And then stack those after the fact, because it's going to save each individual frame on my computer that I can then use to put into an application to stack up all those images. And believe me, if I had 1,000 frames of the moon, the way it is right now, stack them up, the result is super clear, a lot of detail, almost no noise. It just eliminates most of the noise. And what noise and sharpening that it doesn't do, I can do that in post-processing. Well, we have 8:33. I've gone 3 minutes over my time. And I'm going to close it down now. I hope I've given you an insight on my world, what I do, how I enjoy it, and what astronomy is about for me, and what taking astrophotography is, what you can do. There's many different applications that you can do. I use SharpCap a lot. Other people use Sequence Generator Pro, which is a very expensive program, and it does a great job if you're into total remote control of your observatory. I don't have a totally remote controlled observatory, just the telescope and the focuser, and that's it. And that's all I need for this guy. So I really appreciate you guys checking in on me and following what I'm doing. And this is the end of the session. So take care and have a good night.